Introduction to hypothesis testing. We're going to describe the purpose and process of hypothesis testing and learn how to correctly state hypotheses. First off, what is a hypothesis? A hypothesis is just a claim we are trying to test. For example, did the intervention increase the proportion of patients who received flu shots? Has isolation due to the pandemic caused increased depression in Alzheimer's patients? Does the DASH diet decrease blood pressure? All of these are questions that we would want to find the answers to. These are all claims that we are trying to test. There are 5 steps to hypothesis testing. The first one is to state the null and alternative hypothesis. Second, to propose an appropriate statistical test. Third, we need to check assumptions of the chosen test. 4, we're going to compute the test statistics to find the p-value. And 5, we're going to use the p-value to make a conclusion. We'll go further into each of these steps on the next slides. When in hypothesis testing, you will always have a null hypothesis and an alternative hypothesis. The null hypothesis will always use the equal sign. This will say that there is no difference between our two samples. So for example, our null could be the proportion of patients who received flu shots before the intervention is not different from the proportion of patients who received flu shots after the intervention. Usually what we're looking for is the difference. The difference comes in our alternative hypothesis. So for example, the proportion of patients who received flu shots after the intervention is greater than the proportion of patients who received flu shots after the intervention. This is the claim that it's going to be greater than, that our intervention helped get us more patients to get the flu shots. We will go through our test to see if there's evidence for this claim or if there's evidence against the claim. Next, we will propose an appropriate statistical test. There are a whole bunch of different tests you can see. These ones are from your textbook. And the test will be based on these different things. So first, it'll be based off the number of variables of groups. So depending on how many groups you have, if you're comparing 2 groups, if you're comparing 3 groups of people, that will change which test you're using. If the groups are independent or dependent, so if the 2 groups are from the same people, or if the 2 groups are different groups of people. If they're the same people, they're going to be dependent. If they're different groups of people, it's going to be independent. Level of measurement, so is your data categorical? So is it based on categories? Or is it numerical? If it's numerical, is it ratio? Or also we could have ordinal or interval. Those will all change which test it's going to be. And the last one is normality. So if it is normal, if our distribution is normal, then we can use the test for normality to see if we can use our parametric tests. If it is not normal, then we have to use the non-parametric versions, which you can see over here. Most of them have the non-parametric version if it is not normal. So we will go further into how to do each of these individual tests, but the process is the same for all of these. We first set our null and alternative for all of these. We're still going to get our p-values, and we'll still make a conclusion. So once we have our test, we have to check the assumptions for the test. Each test is going to have its own assumptions. Some typical assumptions would be normality. Again, all of your parametric tests have to be normal. Equal variance across groups is also seen as an assumption, and then independence would be another assumption. So once we run the test, we need to figure out, is this increase statistically significant? So for example, if before the intervention we had 50% of people getting their flu shot, and after the intervention we have 55% of people getting the flu shot. Is this difference big enough to be called statistically significant, or did this just happen by chance? Just by looking at these 2 numbers, we cannot tell if this was actually due to our intervention or it's just a different group of people got us these results. That is why we have to do the hypothesis test, and it'll tell us how likely this would have happened by chance or how likely it is to be statistically significant. So we will use the software to compute the test statistic to find the p-value. So the p-value is the probability that the null hypothesis is true. So if p is less than 0.05, this means there's less than a 5% chance that the null is true. So this less than a 5% chance that there's no difference, that the two samples were not different from each other. So once we use the statistical software, we'll get the p-value, and then we'll use this p-value to make a conclusion. So this conclusion will be based off of alpha, which is our level of significance. This is the chosen level of error. And this will depend on which field you are doing the test in, but usually it's 5%. So if p is less than alpha, say p is less than 0.05, we're going to reject the null. This means there's evidence for an alternative. That means there's evidence that our groups had a difference. If p is greater than alpha, we fail to reject the null. This means there's no evidence that there was a difference. We can never accept the null because we're not testing the null, we're testing the alternative. So we just say there's no evidence for the alternative. And that is how you do hypothesis testing. So again, this is going to be the same process for all of our different tests. The only difference in the process is going to be what we put into our statistical software. Then once we put that into the statistical software, we get our p-values. And if we have more groups, there will be more steps at the end because we will have more groups to choose from, but we will go throughout that with the rest of the semester. Hopefully this gives you an overview idea of hypothesis testing.